transcription has starting recording. Yes.
Mm-hmm.
Now at the end, then where will the recording be? That is the question.
I'm not sure.
We'll find out. I'm sure it can't get lost. I'm sure it must be somewhere. Right. Okay. Let's maybe start now, please, with the discussion. I'm sorry that you missed the, but we didn't quite do much. I think you can still catch up if you follow carefully today.
Okay.
Welcome then to our discussion, Kaya.
Thank you. Thank you.
Good. And I'm sorry for the. I'm sorry that you missed it. I'm sorry that you were not able to get hold of the recordings. Thank you. Okay. Thank you so much. Let's then start. We are discussing chapter, I think it's chapter 5 on the differentiation of functions, and we discussed this. I think the last two sessions were about differentiation. The issue then here we have a function f. I hope you can see my board, Kaya.
Yes, and we can see.
Okay. Does your name does your name have something to? I mean, does your name have something to do with home, Kaya?
Definitely, as an African.
Okay. Excellent. Yeah. Excellent. Yeah.
Means home. Yes.
That's good. Yeah. There's one language where I come from where the name Kaya means exactly home. Yeah. Languages are very beautiful. So here we have a function f of x, right? And we are asked to, this is given, f of x is given, and we are asked to find its derivative, f prime of x. It's another function which of course, it depends on the same variable x. We call it f, and the differentiation of f, or the derivative of f, rather. Then the question is to know, if we are given a function f, how do we compute? So this is given. F, the function f is given, right? Let me take an example rather than remaining in the abstract. X squared plus, maybe take plus 4 for x plus something like what? Please give me a number there, please, that you like. No one is willing. Okay, let me take that one. This is given. How do we compute the derivative of the function f? How do you compute here f prime of what is f prime of x, please? Anyone?
2x.
2x is, yes, 2x. This is quite easy. Plus 4, right? And 5 here becomes, of course, 0, because 5 is a constant. Its derivative is just 0, right? We discussed some rules for differentiation last session. What was, again, our first rule for differentiation? We have the power rule. Do you remember the power rule? Let me see the attendance today in the class. How many people are there? Why the number is decreasing? Now we have just less than 20 students attending the class. What's going on? Why the number is decreasing? Only 20 something. I think this is just unbelievable. Why only few students are attending the class? Anyone who can guess?
How many did you have last time, Prof?
That's a good question. Nearly 60 something or 70, but now we are just around 20 or 30, and I don't know really why.
Prof, are you sure that there wasn't another class there on the other side? Because
there
it's
is
happened before.
I can check. I can guarantee you there is nothing. I see only this.
The
Yes.
lady who dialed in late and said they were in another session instead of joining your session, did that get resolved?
Yes, I can see now. Yeah, because we are now we are using the very first platform, the one we started on the 10th of August, and there is nothing else. Well, people maybe are busy or they're not interested. Yeah. Good. Let's then continue. Sorry for that interruption. Let me take another. So last time we discussed a few rules of differentiation that you must know in order to be able to find f prime of x if you know, sorry, f prime if you know f. The first rule was the power rule, right? And the form of the function is x power n, where n is a number, any number basically. How do you find the derivative of this function? Kaya, you can follow. This is basically what we did last time, right? The power rule. If you have a function of the form x power n and you want to find its derivative, the rule is simple. How do you compute this f prime here, please?
It becomes nx to the power n minus 1.
Yes, n times x to the power n minus 1. Yes, general rule, right? Now we can even extend this one now today. We can extend it in the following way. Assume we have a function of the form. Let me take now a general function which has also this a form of a power. Let me take, for instance, u function of x. U is another function of x, and take u of x at the power, and you take it everything or function u at power n, right? Who can guess how can we find here the derivative of f? Who can find the derivative? Yeah, I'm using what they call the chain rule, but it's not important to know even the name. How do you compute this derivative? If u now is a function, you do the following. If no one can answer, n, right? You take n, you multiply by u prime of x, or even before u prime, take first u of x itself, right? Yes, but continue. Who can continue, please? What will be the power here, please? Which power do you have here? Power. Please, are you following on the board? Yes. N minus 1, right?
Yes.
Good. As you are not done yet, you multiply by the derivative of the function u itself times u prime of x. Any question there? Does this make sense? Compare then with the previous, the chain rule. Can you compare with this one? What is missing there? If you, here we have n. Oh, sorry. Can you see can you see everything on the board? What is missing here? We have n times x n minus 1. Nothing is missing, basically. This is an important formula. So let me repeat it again. As a teacher, that's how we teach. You repeat a function u of a variable x at the power of a number, say, for instance, a number n in general, rather, right? How do you compute this derivative? Let me show something like this. So with the abuse of notation. Okay, who can repeat it again? We take n down. Who can continue, please? U, this function, we take it at the power. I'm not like talking alone, you know, power or at the power of. Who can continue, please? Are you there, please? Can you hear me?
Is it not n minus 1? I don't know.
Okay,
Give me the
thank you.
time.
Oh, okay, now and we multiply by the derivative of u itself, right? Great. Excellent. Good. Now let's take an example. We 3x or 3x squared, 3x say squared plus 4. Elevate this at the power of 3. Sorry, my hands are getting hot. Assume this is the function y. Who can then compute y prime? What is y prime of x? Anybody, somebody, Kaya? Today you answer most of the questions.
I can't answer the questions because I'm in the dark here.
Yes. Now we take here now the derivative. We apply simply the rule. The rule is here before you here. You have see the function is there. This is the function u at the power of 3, right? So we take 3 come that, right? Multiply by 3x squared, right? Plus 4. And thereafter, the power becomes 2. Take 3 minus 1. And we multiply by the derivative of the function u. This means the derivative of 3x squared plus 4. Right?
Mm.
Right. Okay, now what is now the final answer? This gives you 3 multiplied by 3x. You don't need to find to multiply this, only find you can stop after there is no more derivative in the formula. 4 power 2, right? Multiplied by, which is the derivative of 3x squared plus 4?
The derivative.
Yes, of
6x.
3x squared plus 4.
It's a 6x.
Okay.
Yeah,
Yes,
just
this is
6x.
powerful. 6x, yes. Yes, I can hear a voice, a familiar voice. Let me see who is that. That familiar voice, a voice. I don't remember. Okay, but in any case, good. So this is the final answer for y prime. Good. We discussed also another rule for what was our second rule. I think it was the exponential function, right? Of course, we have something like also, if you have a function like 3, any constant c, multiplied by, assume we have this form, c is a constant, say multiplied by a function u. How do you compute the y prime here? You see here, I mean, this is c, u of x, since u is a function. How do you find the derivative of this product? It's very easy. Sorry. I'll fix my computer tomorrow. I have an appointment for my new computer. Will be when our next session will be very beautiful because I will have to write with my pen on the board. It will be very nice. You'll see my beautiful handwriting and not this nonsense that I'm writing here because I'm writing with the mouse. Great. How do you find now this derivative, please? You you simply keep the constant unchanged, and you simply multiply by the derivative of u. U prime of x. Every time we finish the session, everybody is happy, and I go to my bed knowing that I did a good job, expecting that next time everybody will come back and they will even invite those who didn't come. But I'm surprised that next session the number goes down as if last session was a total disappointment. Eh? Well, let's take an example here. I think this is very basic. We discussed this again last time. If I consider, for example, the function 5 multiplied by x power 3 plus, say, 5x power 7, and we put everything here. Let's leave it, maybe. Okay. Yeah, what is the derivative of this function, please? Y prime. How do we find that the derivative of that function? Kaya, can you apply this formula? You see here we have a constant. C is a constant, a number, a fixed quantity, right? And we multiply by this function x power 3 plus 5x7, right? How do you then compute this? Here you see the formula. We keep C unchanged. The constant remains unchanged. So here we have simply 5, and we multiply by the derivative of x3 plus 5x7, right? Derivative. So we simply take this derivative. What is the answer now? Five multiplies by
It becomes
are you
3
there, please?
squared
Yes. Yeah, 3x. Yeah, 3x squared. Yes.
plus 35x to the power 6.
Excellent. Yes. Plus 5 times 7 is 35. X power 6. Yes. Excellent. Yeah. Maybe another one will be the exponential. That's one we did last time. If we have the function e power something, like, first, if we have e power x, what is again the derivative of the derivative of y? If we have this function, what is the derivative, please? Yeah, we can find y prime.
Is the same e?
Yes, same thing. Yes, yes, same thing.
Yeah.
I can remember your voice. You were there last time. I don't know the name, but I can hear the voice. Right. Now, what's your name again, my friend?
Stuart.
All right. Good. Now, if we have now in general e power a function. Sorry, with the font. Good. If we have now e power a function like u of x, how do you now find this derivative? How do you find y prime?
So y prime becomes u.
Yes.
Ux.
Ux. You say ux? No.
I said
prime.
u.
U prime.
Yeah.
Please. you take the derivative of u and multiply by the very same function e power u of x.
Yeah.
Right? Good. This is how you find this derivative. You keep the same thing here, but you multiply by the derivative of the exponent u prime. And we did some examples last time. Take for instance, Kaya, are you still following even if you missed the last session?
Yeah, no, Prof. I'm lost, but I don't want to waste everyone's time.
No, really.
So that's
Let
why
me
I'm
explain.
asking for the
Give you
recording so that I can go through the stuff
Yes.
on my own. Mm.
Yes, let me give you here an example, Kaya. You will definitely follow up. You'll catch up basically. Only please be alert and be there, right? So don't give up. Let's have this function e. This number e. I mean, you might be asking yourself, what is this e? E is the number. This number e is defined as follows. Just to this number e is given by close to 2.7718. In fact, it has too many other decimals, but we can stop there. 2.718. There are too many other decimals. This number is given by the logarithm of this number e, in which basis now? Yeah, maybe I could say rather, of course, logarithm in the same basis. I think this is clear. The number is e 2.718, right?
Good. Thanks, Prof.
Good. Now, how do we compute here now the derivative of this? Once again, please, maybe someone's at my gate. I want to open for someone. So, okay, please give me 1 second. I want to open for my wife. She's at my gate. 1 second, please. 1 second. It's working from home. Okay, I'm coming. Please, 1 second. Oh, thank you. I'm back. Thank you. Sorry for being late a little bit. Yes. How do we now here compute the function y prime or dy over dx? Another way to write the derivative, dy over dx. Right. This is given by. Anyone please to answer the question? How do you compute
So,
the derivative?
I
Yes.
think we first differentiate the power of E.
Very good.
Then we bring it down.
Exactly.
Yes.
So x squared plus 4x, right? We take this derivative here, x minus 1. This, sorry. Minus 1. Right? We take this, yes. Multiply by what, please? The same thing, e power the same function, right? Plus 4x minus 1. It's clear? And now, what's now the final answer? What did you stop? You started well. What did you stop to answer? You were in the good. We were talking. Why did you stop? Now we have x.
Okay, then we get 2x plus 4.
Yes, 2x plus 4. Okay.
Multiplied by e and e to the power. What's that?
Yes, to the power of of all function. Great. Plus 4 multiplied by e to the power of x squared plus 4x minus 1. Good. What is it? What is the derivative over x? This is another notation for y prime, right? Same thing. Basically, maybe let me conclude with logarithm. See, even if you are not there fully, you can still follow and cover what you can put the mute, please, unless you want to answer. You mute your mic, please, everybody. Yes, Anvile. Can you put the mute? Great. Okay.
In school.
Can you mute, please, your mic? It's Kylie. Can you please mute, please, your mic?
Okay.
Okay, good. If you are still okay, good. Now done. Okay, great. Now let's go. Let's look also at the function, the logarithm function. Oh, sorry. The function y equals ln the logarithm of x. How do we compute this derivative? The logarithm is the logarithm of x. This, remember that by definition, this is simply the logarithm of x in which basis? What is the base of this logarithm that we call ln?
10.
Not 10.
E.
E, yes, E. Thank you. It's
E. Okay.
When the base is E, this logarithm is called ln. I mean, it's the natural logarithm, ln, ln of x. Good. Excellent. Right. And in general, even we can do this, but I don't want to waste your time. But in general, the logarithm of any number x in any basis, say for instance, in base b or a, if we say that this number is equal to y, or let me say to b, what is the meaning? What does this mean again? In which case do we write log x in base a equals b? In which case that is true. What does this mean? Basically, come on, simply you write e to the power of e, right? E to the power of b is equal to x. Right. That is the meaning. I know that doesn't mean too much for some of you. Let me write it like this. For instance, log. What is the logarithm of 100? If we take the base as 10, what is this? Basically, the question is, what is that, please?
It's 2.
2, yes, 2. Can you explain to Kaya what does it mean?
It means that
Because
10 to the power 2 is equal
it's
to
10 to the power of 2 equals 100, right? 10 to the power of 2 gives 100. Yes. We discussed this last time. What is the logarithm of, what is the ln of e? What is ln of e? This number e, the base. What is that?
It's 1.
Is 1. Why?
Yeah.
Because of course,
Prof,
ln can be seen.
you waiting for an answer?
Logarithm, yes, of e, and we know that for ln the base is itself e, right? And for every number, log of a number in that base is just equal to 1, right? Because of course e power 1 gives you 1, right? Was time again, but the most important question here and now is, how do we compute the derivative, or how do we differentiate the function ln x? Right. How do if we have, how do we compute y prime? Who can give me the answer again, please? Say that the last time.
It's 1 over x.
Yes, 1 over x. Very simple. 1 over x. Right. Good. Now, in general, then, if we have now a function u and we have ln of u, ln of a function u of x, how do we compute its derivative? How do we compute y prime?
It's the derivative of the function over the function.
Very good. Of the function over the function itself. Very important. And all these formulas have been tested and justified and proven in many ways. So it's not like just for the sake of writing a formula, but it has been just, it's exactly this. We can prove it, but if I was giving a course in mathematics, in the Department of Mathematics, we could have done here much of the proof. But for now, we take it as it is, and we believe that it's correct. But it is true, it's correct. Great. Can you take an example, please? So you see, you need to understand all these formulas. It's an open book exam, but yet you still need to know them, so that you may not waste time trying to find out in your study guide what is the formula. Well, if you know the formula, it will save you time during the exam. Find the derivative of the function ln my n. I hope you can see my handwriting. If I will then write like this, ln is L and N, right? Say of, if I take the function x power 3 minus 6x plus 4. How can we compute the derivative of this function, y prime? Someone please to answer. I must diversify. I might ask questions to many other, not only one student. Who can answer, please?
I think first step is to remove the brackets. So basically we multiply everything in brackets by ln.
Apply the formula here. Go back to the formula here. Here the point is to always remember the form of the question, please. Here we have ln of all of this, right? It is not per se a multiplication. It's just the logarithm of a quantity, right? Logarithm of this sum. And this is, please apply the formula. Observe that this is exactly what we have here. Look here, y equals ln u of x, right? This is the logarithm of this quantity. Here we are not multiplying. We are computing the logarithm of something, right? Ln of this quantity. What we call u. Then here, then the formula will be, we take this quantity, this is what we call here the function u. I call this u of x. Right? And how then do we compute the derivative? Of course, we take u prime. We divide by u of x. That's all. Right? How's the following? So what do we have here then? We take it will be x power 3 minus 6x plus
Prof,
4.
there's a hand up. There was a hand up.
And I told you, please, if you have a hand, I can't see the hand. Just unmute and speak your mind. You don't need to ask for permission here to talk. Okay. Right? It's a class, it's not a meeting. Please just raise your point of order.
No, there was a hand up. It disappeared.
Okay. Please feel free to ask your question if you have any issue. So here we take this function and we compute its derivative and we divide by the same function, right? We divide by x power 3. I'm sorry if I didn't see that hand. 6x plus 4. Right. Okay. Which is now the final answer. The final answer. I can't wait when I get my computer. I can write with my pen or my. It will be very, very nice. That will be my best lecture ever. Yes, equals
3x minus 6
yes, 3x squared, yes.
minus 6
Minus
all
6.
divided by
Very
x.
good. Divided by the same thing, x power 3 there, right? Minus 6x plus 4. Good. At least our derivative here. No more ln in this answer. Thank you. I think that's all we have for this so-called maybe activity on page. I'm on page 65. Let me give you this example or this exercise. Let's take y equals. I take the function square root of x squared plus x squared plus 12. And we just get to find the derivative of y. How do you proceed then to find this? You see, like
can I try this one?
Yes, please go for it. That's good.
Okay, I will start by removing the roots. I would say before we go to derivative,
Yes.
I would say bracket equals to bracket
Yes.
x squared
Yes.
plus 12 to the power of half.
Yes, good. And that's it. That's the key, right? Right. So you first write it as a
Then-
power. Now, yes.
Okay, we would say no. Can you? Okay. Can you, I just want to do it
Go
on my
for
own
it.
way.
Yes, go for it. I'm not doing anything. I'm simply copying what is there.
Okay.
Yes. I don't do anything. I'm following you.
So now
I'm your secretary.
Okay, so now I'm differentiating.
Yes.
Differentiating. Going to
Yes.
be 12
Okay.
half.
Okay, but
1
before
over
that, which formula use? Okay, which formula are you using to help others to follow you as a teacher? Which formula are you using?
The prime y. Prime y.
Yes, it's like a u power something, right? Like a u of x power something, right?
It is power something.
Yes, good. Let me call that something n. Right? Right.
Yes,
So
correct.
it's always good. It's always good to try to find in the notes or in the study guide which form. I mean, which form are we dealing with? Guys, do you hear me? When you have any question that you have here for which you are asked to compute the derivative, try to link the particular example that you have there with a general rule in the study guide. Are you with me? I'm saying this. Always try to see the problem that you have at hand can be linked with what other problem that you have already discussed in the study guide. That is the key that you have to. I mean, that's how we work here in mathematics. The model that we have, if you have a problem, try to see which model, I mean, which form, which shape do you see there in connection with what has already been given in the study guide, right? Okay, good. So now we can see that this is like a power function, u of x power something. Now, how do you compute this derivative?
Okay, it's going to be half, or you mean the one with the ux or?
Yes,
or the sum.
Yes, the ufx, this one, yes.
Okay.
N, right?
Okay, when we derive this one, it's going to be n multiply bracket.
Yes.
U multiplied by x bracket n.
Is u of x is of n power n minus 1, right?
Minus 1. Multiply.
Good.
By u.
U prime.
By u prime, yes.
Always, remember, u prime of x, right?
X.
Good. That is all. So here we do now you apply the same formula. You see, you always connect with what we already, the form that we already know. Great. If we now come back to our particular case, what do we then obtain?
It's going to be half.
Yes, half. This half comes. So this half here comes down, right? Half our n.
Multiply by x squared.
Yes.
Plus 12.
Yes. Sorry. One second, please. Your secretary is slow. Sorry. Plus 12.
Plus 12. Close bracket.
Which power?
To half minus 1.
Yes, half minus 1. Minus 1. You multiply by what?
You multiply by the bracket.
Yes. Yes.
x to the power of 2 plus 12 prime.
Yes, and what is that? Give me the answer directly. Yes, man. Give me 1 minute. 1 minute. I'm coming to open for you. Okay. Continue. Continue, my friend. Sorry, I'm going to my brother.
Okay.
Yes, multiply by 2x.
X, so 2x.
Right.
Plus to the power of 1. Okay. Plus 0.
Good. Okay. So this is only right, and we are done. Right. Here we are done. You can continue if you want. You can continue to simplify and write. Will be, but this is done. There's no more. I can stop here, but maybe we can now simply write 1/2. Right. This is x power 2 plus 12. Right. What is now power minus half, right? Multiply by 2x. Right, one can simplify there, and we are done here. This is exactly x. This can go down, right? Divided by a negative power will be, if you bring it down, it will be like this. If you want, right? Power half. Okay, remember a number power half is simply equals to the square root, right?
No.
This is simply then x over. Sorry for putting you under pressure, Kaya. I don't want to put you under pressure at all, but just to because you were not there, just want to try to help when where necessary, right? Square root of x squared plus 12. All these are just manipulation, but then we've already done the job at this level, right? Great. Now, who can do the next? Please give me another second. I want to open. 1 second, please. I'll be back within a. Okay, I'm back. Sorry for a little bit going a bit out. Okay, great. Let me take now 2 more rules, and we are done with this chapter. 2 more rules. One rule, the first one is called product rule. Very beautiful. Before we look at the product rule, let me first remember. Sorry, let me first remind you the sum. How do we compute if you have the u of x? Are you there, please? Are you back? Plus. All right. Plus v of x. Here you have 2 functions, u and v, right? And let's get to find the derivative of the sum. For the sum, there's no problem at all. Is as intuitively, I mean, as the intuition dictates you, if you have two functions, u and v, and you want to compute the derivative of their sum, you simply take at u prime of x plus v prime of x. This is easy to prove, right? So basically, I'm saying that the derivative of a sum is equal to the sum of the derivatives, right? U prime plus v prime. We have been doing this all the time. For instance, if we have how do you compute x, the derivative of x power 3 plus x power minus 4. Let me take it in 1, 2, 4 here. How do you compute this the derivative? Elementary, but I think you can see. How do you do that, please?
It's x squared
Yes.
plus 8.
Yes. So you can see what we're doing. We first take the x power 3 and we take its derivative, right? And we also take the other part, 4x power 2. And we take this at the power of, I'll take this derivative, right? So we can split without any problem. So here we have exactly 3x power 2, as you mentioned, plus
8x.
yes. See, so we have been using this rule already. You simply the derivative of a sum is the sum of the derivatives, right? Easy. Now look now at what we have for the product. Assume we have the function y, which is given as a product of two functions, u of x multiplied by v of x. V of x. Do you see my v is very beautiful, right? The letter v. Right. Then this is a product. Remember, if there's nothing, though, you assume that it's a product. Great. The question is then, how do we compute y prime here? How do you compute this derivative? What comes into your mind if you are honest? What comes quickly in your mind? Y prime. Kaya, what comes in your mind quickly to find that function y prime? If we want to find the derivative of u times v, what does your mind tell you immediately? Anybody else, please, here? I wish I knew already all the names. Joyce. Yes, Kaya. Yes. Okay, can you try something?
I don't know.
What comes naturally in your mind?
Why?
I think I can say the product rule.
Yes, yes. Yeah, it will be then what? It will be u prime, right? Very easy to say u prime. I'm telling you, if you say that this is it what comes in your mind, you might be lying, right? Do you believe me? This is what comes exactly in your mind. In my mind as well. The first time I learned about this product rule in maybe some 30 years ago, maybe some 32 years ago. Right. U prime times V prime. But this is not correct. This is not correct. Right? I remember I have a former pastor, when he wanted to explain to us a verse in the Bible, he first tell us, let me first tell you what the verse does not mean before you can understand what it really means. First, I will tell you what the verse does not mean before you can understand what it really means, right? So here also, this is this answer is very tempting, but please don't. Don't consider it. Now, the exact one, the true answer then for the true answer is the following. So the derivative of u times v, let me copy it again here. U times y, now the red, I don't like the red color. You have free plays from cell C. Win bundles, gaming cost. I don't play games, you guys. I don't play games. Are you there, please?
Yes,
U,
we-
okay, thank you.
Yeah, Professor.
Ux times
V of
V.
X. Oh, sorry.
Yes, no problem, Sia. Is Sia
No.
Bonga, right?
No, it's Musia.
Oh,
So-
Sia.
Yes, it's U prime of X times V of X.
Yes, equals.
Plus ux times
Yes.
v prime of x.
Yes, u prime of x multiplied by v of x, right?
Okay.
See how it's now the true formula. Plus
Plus u of x
u
times
again unchanged, right? The original u multiplied by the derivative of v. Yes, you see. Excellent. Where does this come from? It's proven again. We can use we can find a proof for this. It has been done long ago by mathematicians. No need to spend time in the proof. Great. This is how we then how you find the derivative of a product. This formula is called the product rule, right? On page 65. Great, 65. Very good. Let me take an example. Let's take an example to explain or good. An example, let me take for instance 3x squared plus what? Plus what, Monsieur? Just give an example. Why only me? Please give an example, Mr. Monsieur. Plus 4x.
plus 4x.
plus what again? Just give a number, man.
You can add a constant in the as the last term.
Yes, yeah, put it. Give it me. Give
7.
maybe
7.
7. Yeah, 7. I see you like 7. Multiplied by no problem. I'm joking. Times.
Let's make it a bit complicated. It's e.
No, we have to. Here we are. Want to I'm teaching the product rule, right? So I want to have a product of two functions, right?
Yes.
Yes. Now continue. Now give me another function, please.
Okay. Can I take the natural log function?
Whatever you want, Michelle. You are free.
Oh,
Give an example.
It's
Log,
len. It's
len.
len. Yes.
Huh?
It's len of 6x squared.
Huh. No problem. X squared. Only x squared. You don't want to add something. Maybe
No. Simplify.
Maybe 3x.
Yeah, you can add 3x.
Okay, no problem. Okay, let's leave like that.
Yeah, the closing parentheses. Yeah.
Yes, it's fine. I can even take it off.
All right.
So here we have, as you can see. So as I told you, it's always good, guys. It's always good to link when you have a problem. You know, why do you fail? Why do you fail to solve a question in the assignment or in the exam? It's basically because you fail to link it with a model in the study guide. I wish I could say that in many languages. Your first job as a student then of this module is to try to find in the study guide which model am I dealing with here. The question that the lecturer has prepared for me here to test my understanding, right? is here. Then, if I open the study guide in my mind, which model can I link to this one? Right? Where can I mean, which link is there? Or if I have to transfer this question in the study guide, where does it fit? I mean, by the way, to transfer, I saw something yesterday on Twitter. Like I said, I wonder how can I transfer the money in my mind into my bank account. What was I was laughing yesterday all the night. So I wonder how can someone transfer the money? I have too much money in my mind, but I don't know how to transfer it in my bank account. Try to take then the question that you have here. Try to link it to a model in the study guide, right? If you fail that, that is exactly the problem. That is where you fail the question. You fail to identify it or to connect it to the model that you have in the study guide. Am I lying or am I speaking the truth? Are you with me, please?
Yes, we're with you, Prof.
Yes. I'm saying that, Mr. Musia, any question that you will fail in the study guide, in the exam, is that you didn't link that question. You didn't link that question to some model in the study guide. So please always try to identify a model in study guide which links, which is like a replication of what is given to you there. Right. Right? Clear? I say yes or no. Come on, guys.
Hello,
Okay.
hello, sir.
Yes, Justice.
I was a little bit late.
Oh man, sorry.
On this y is equals to 3x squared plus 4x plus 7.
Yes.
Where did we get it?
Musia, can you answer that question?
No. It's an example that I have on
Very good.
paper.
Yes.
And the reason why it's because it includes the product rule as well as the chain rule. So sometimes you get confused as to which rule you apply before which. So
whatever, it doesn't matter.
Okay.
It doesn't matter, Mr.
Okay, let me check. Here we have y is equals to 3x squared.
Yes.
Plus 4x plus 7.
Yes.
So are we deriving here and say 2 times 3 is 6x squared?
No. Yeah, yes, but before that, before you do that, first you must look at the bigger picture. That is it. Before you go into the details, first you must have the bigger picture, right? First the bigger picture. Here I see a big function, 3x squared plus 4x plus 7. This one here, right? Multiplied by another function, ln. So basically, I see a bigger picture as I see y as a product of two functions. That is the first step. It's natural, right? But before you, I want to ask, Justice, did you get the answer? It was just an example that Musia provided. I pushed him to provide an example, right?
Yes, sir.
Justice, are you okay there?
Hello?
Yes,
I'm still listening.
Okay, you asked the question, where did we find these functions here, these two functions? And it was just an example that Musia gave. Right. Are you okay with that?
But this example is on the basis of what is the derivative on the top.
Yes,
of y prime is.
Yes, exactly. I asked them to provide an example of two functions so that we can apply the product rule. Here we are learning how to compute the derivative of a product of two functions, right? And then ask them, Musia, can you give me any example that you want? Just something, right?
Okay.
Because I don't want to be the only one providing examples that you may ask, it's suspicious, Prof, where are you getting these examples? So now you provide yours, and then we can compute that. I think that's easy to get. Thank you for asking, Mr. Justice. Okay, now we apply. Mosia, I don't know if you are the one who asked the question. Here we have then, you see the bigger picture, and here you see just very clearly a product of two functions, right? So this is the first one, I can call it U.
Mhm.
And now the second one, you call it V, if you like, right? And it's that moment, it's like I think this is even the way every mind works, or even in every field. You always try to see when a medical doctor has a patient, what does he do basically? He tries to link the case that he has before him, right, to something general in the book, or I see even some doctors will open the book if they are confused, to open the book and see, okay, which these symptoms, where can I link them? Which theory is available there to help me to solve this case, right? This is the same thing here also in mathematics. You try to identify which model are you dealing with here. Once you get that must be the first step you should do. The question, you read the question 2 times or 3 times before you try to solve. I wish I could say that once you have a question, before you start solving the question, are you listening to me, please? Identify in your mind, where are you in the study guide? Which model are you busy with here? If you fail that, forget the answer. You won't get it. But once you see, here I see a product. Here they ask me to compute, for instance, the maybe the profit or whatever, the revenue or something, a linear model, or you always try to find the model that you have in the study guide, which is before you here, right? Yeah, I think this is the first time I understand that. That maybe that's the reason why many people fail mathematics or many other subjects. You fail to identify the model that you are dealing with, right? If you don't get it, if you can't say, I can see, you see the bigger picture, and you link your problem to something in the notes, in the study guide, or in the whatever, you can't solve the problem. Any comment on my comment?
Now, what to
Sir,
Yes.
I think, can I try to complete this equation?
Okay, yes. Sure. But first, can you comment on comment on what I've just said before I allow you to solve my question?
What was the question?
Thank you. I'll say this. This is what this is what I was saying. When you open that exam paper, right? Question 1, right? You must first understand which model in the prescribed book or the study guide am I dealing with here, right? Any question, try to identify which model in the study guide. If you can open your book, your study guide in your mind, which page, which chapter, which section of the study guide is the lecturer busy here asking, testing my understanding there, right? That's what I'm saying, right? Don't start just solving a problem before you identify the model that you are dealing with in this prescribed book or in the study guide. That's what I was saying. Can you comment on that? Okay, let's continue. Okay, now you can answer the question.
Let's start by substituting UX. I would say my UX
Yes
is equals to
yes
3x squared plus 4x
yes
plus 7.
Yes, so this is like UX. So we have here UX multiplied by VX, right? Good.
Yeah.
Good. And now see.
Okay,
what
then
you
my
see- yes. Now you can go to the model. Let me first do is okay equals, and how do we find this? Equals. What is that derivative of u? Is yes, please. First you give me the formula. Yes, u prime
is u prime x.
Okay. Yes, I'm typing for you. Multiply by
Multiply by vx.
V of x, yes. Without
Plus
plus
ux.
Ux.
And multiply by vx prime.
Yes, very good. That is it. Once you are there, you are done. Once you have already identified the model, right? There is literally nothing more to do. Ux, sorry, I'm typing for you. I'm slow. Multiply by
vx prime.
Yes, very good. That is it. All right. Now we can simply replace this u and v by their values, right? So now we have now what's now u prime now? It will be 6x.
Yeah, 6x. Yeah, 6x plus 4.
Yes.
Plus 0.
Yes, plus 0. Yes, right.
Then brackets.
Multiply by
so v, it is ln x.
Ln of x. Yes, this one we will not touch, right?
Bracket. Yeah, bracket is 6x squared minus 3x.
Minus 3x.
Yes.
That is one step. Plus.
Plus
3x
squared.
3x squared. Maybe I can jump here on the next line, please, to save because there's no space there, right? 3x squared, yes.
3x squared plus it's 4x.
Plus 4x, yes.
Plus 7.
Yes. Plus 7.
Then
I hope everybody is following. Please, I hope everybody is following.
Then our v prime.
Yes, now by v prime now. Okay. What is v prime now here? Everybody, can you see what is v please here? Right. Now what will be now v prime?
V prime is going to be 1 over.
Not 1 over. How do you find the ln of this ln of a function? How do we find that derivative? Do you remember ln something? What is ln of u derivative or something? Let me take ln of g. How do you find this the derivative?
It's a derivative of g over g.
Very good. It's g prime over g, right? G prime over g, right?
G prime over.
Yes, I can hear you. You are trying to try to make sense of this. Now we have here. Now we want to derivative. Now we want to compute the derivative of. Maybe I can write it here down, but no need to. We are here now. See, we are computing the derivative of this function. Here, please. Right? How do you find that now? This is ln of this g. So we take this g, the derivative over g. Okay. Can you please now? Can you please now continue? So it will be then. How do we find the derivative of this of what is in bracket? It will be 12x, right? Minus 3. Good, right? So here we have 12x minus 3, and we divide by what?
6x squared minus 3x.
Yes, good. 6x squared minus 3x. Good. Excellent. Good. Excellent. That's all, guys. That's all. Now we have our y prime here. Now, no more. We are done. There's no more derivative here. Everything is there. It's this sum. Yes, great. Let me repeat it again, not everything, but just to remind you the formula, the last one. Maybe we still have 10 minutes. Let me now, the last rule, we won't come back to this one next time. Let me give you the quotient rule. Quotient rule. Right, the fraction, or they call it the quotient rule, yes. Yes, excellent. Can you please mute, please, that we may not record, we may not keep a record of your Justice, can you please, can you maybe mute when you don't answer a question, that we may not keep a record of everything. Great. Okay. The last rule that we need to discuss here is the quotient rule. A function y is given by as a fraction u of x we divide by v of x. Again, which formula comes into your mind to compute this derivative? You know, our minds can be lazy, I'm telling you. Y prime? What is y? What comes easily in your mind? We have two functions u and v, and you compute the quotient, and you ask it to compute the derivative of that function. What comes in your mind naturally?
Quotient rule.
Yes. No, are you sure that that's what comes in your mind, Musia? Honestly, what comes in your mind first?
This is the quotient rule, Prof.
I know fully. I know it.
So it's u prime of x times v of x.
What comes in the mind is the following. If you are honest, Musia, u prime of x.
Okay, this would be when I see a function divided by another function.
Yes.
And I'm asked to find a derivative of that function.
Yes. Are you not tempted to do this?
Prof?
Are you not tempted to do that?
At first, that's what I was
That's what I'm saying, Musia. That's what I'm saying, Mr. Musia. I'm trying to first to show you what is the wrong answer, what it does not mean, before you can understand what is the true answer. Right? Yes, yes. But you must discard all the false answers, because they will tempt you. I'm telling you, under pressure, this is what comes in the mind quickly, under pressure, right? Or if you are not careful. I'm saying that this is not correct, right? Right. The right answer is the following. You, let me write with our time is u of x over v of x. Let me try to write as clear as possible. If we take this derivative, then now we have the rule, the exact rule, right? The true answer. Yes, Musia. But are you the only Musia, the only one here, Musia? You are asking all the questions. Someone else, someone else should answer also. Kaya, are you?
Prof, I'm here, but I'm listening.
Oh, good. Thank you so much.
I really need
I
more
hope I'm
time
not
to work
studying.
on
Okay, very good.
I'm listening. I'm going to work
Excellent.
on this after the session. Okay.
Very good. Please, if you face any question, please feel free to contact us.
Thank you, Prof.
We are there to help. Right? Excellent. So here now, yes, we can now give the power rule. Sorry, the quotient rule. Sorry. is u prime of x. Yes, Mosia, you want to say something?
Yeah, it's u prime of x times v of x
Yes,
minus
yes,
v prime of x times u of x.
yes. Let me keep the same order. U of x times v prime, right?
Yes.
V prime. And we divide by something.
By v squared, v of
Yes.
x squared.
Yes, vx squared. Yes. This formula is very important then. All is power 2. Yes. It can be also proven with logic. Good. Then let's take an example. Who can give an example? Let me take maybe an easier one to save time. Y equals maybe x power something plus 2x plus, let me take some percent, plus 1, plus 4, plus whatever, divided by maybe 3x plus 2. Right. They ask you to compute the derivative of y. You have a look. You just look at the question, right? I wonder which form is this. You can see exactly that this is a fraction, right? It's a question of two functions, right? And then you go back to the formula. Which formula do we use? Is there the quotient rule, right? We can compute then the derivative here. Yolanda. Joyce, are you there? You can answer please the question. How can you find how can you compute this derivative then?
Can I try, Prof?
Yes, please go for it.
It's not going to be 3x squared plus
Yes.
2.
Yes.
Times 3x
Yes.
plus 2.
Yes, this is, we take this is u, right? And feed down, so it will be 3x squared. Sorry. 3x squared, yes, I agree. U prime plus 2 multiplied by v, and v is, yes, v is 3x plus 2
plus 2
without changing anything, right?
Yes.
Good.
Minus.
Minus. Let me change the color. Minus.
We're not seeing where you're writing, Prof.
Truly, what's going on? You can't see my board.
Yeah, we can see now.
Oh, good, thank you. Maybe there was some internet issue. Okay. Oh, sorry, it comes
Minus.
Yes, minus.
Minus in brackets x cubic plus 2x
Yes.
plus 1.
Yes.
Close the bracket and we open another bracket.
Yes.
1.
Times what?
3.
3, yes, 3. This is now
3.
the derivative of 3x plus 2, right? Yes. Very good.
All over
all over the
All
big fraction.
over
Long.
3
Good. 3x.
over 3x plus 2
Yes.
in all wait.
Squared. Yes. Like this. Very good. You are free to stop there. You are free to stop here. Everything is there. Right? No time to waste to try to compute the exact answer. But here we have already, what it means now is no longer the issue of the derivative, right? That's how we apply the formula. U prime times V minus U times V prime divided by V at the power of 2. Yes, excellent. Right? Any other question that we can? I think that is it, and the time is there. Higher, maybe a word on higher derivatives. What do you mean by here by higher derivatives?
Are you
Higher.
asking me a
Yes,
question,
please.
Prof?
Yes, please.
What was the question? That what did you say?
Oh no, I would just comment on the section 5.3 higher derivatives.
Yeah.
Yes, basically it's like the second derivative. The second derivative, d, is basically the derivative of the derivative. The derivative of the derivative, right?
Mm.
Is called the second derivative.
Oh,
The derivative of the derivative, right?
okay.
That is it. Like you have y, you compute y prime. You see the first derivative, right? Right. If you take this again, y prime, and you compute its derivative, y prime again prime, we call this the second derivative, and we note it by y second, like this, y second.
Yeah.
Right?
Sorry, Prof. How would you, in case of if I give you an example now with regards to computing the second derivative?
Yes, yes.
If I give you an example, like say y is equal to 3x cubed.
Yes.
Minus like 1 over x.
Okay.
Plus e2x.
Whatever. Yes.
Okay, so
an assignment question.
Well, no problem. What if assignment or whatever is not a problem? It's not an exam, guys. An assignment is not an exam. We can comment on the questions. We are free to comment on the assignment questions. Right. It's not like it's a taboo to touch an assignment question. No, it's not. Right. Okay. Here, the first thing, as you understand, is first to compute the first derivative, right?
Okay.
If they ask you to compute the second derivative, they are basically asking you two things. First, you must compute the first derivative, and thereafter you compute the derivative of the first derivative to find the second derivative. Right? Okay.
Okay.
Here now, what is here the first derivative? 9, easy, right? 9x power 2, right?
X squared.
X squared, yes. What is the derivative of 1 over x? Let me do it here. 1 over x. How can you compute this derivative? This is wrote it as a power. It will be x power minus 1, right? And now you take the derivative of this. Apply the power rule, if you like, right? Power rule, what do you obtain? Power rule, x power n.
N minus 1.
Minus x.
Minus 1 multiplied by x minus 1 minus 1, which is minus 2. Right? Yeah. So this is basically 1 minus 1 over x squared, right?
Okay.
Good. Here I write, now it will now be plus, right? 1 over x squared. Next one. How do you find this derivative of e power 2x? E power u. How do you compute this derivative, please? Apply the formula. How do you do this?
The derivative of 2x times e to the power 2x.
Very good, very good. So it will be 2 e power 2x, right? But clear, because 2x has the derivative 2, right?
Okay.
So we have simply as 2 plus e power 2x. Now, what do we do after that step? What do we do then? We have already the first derivative. Now we compute the second derivative, right?
So it will be 18.
Yes. 1 second, please. Yes.
18x.
Yes. Now we're looking for y second. And y second is we simply apply all the properties to y prime. It will be 18. Yes. 18 x, right? Plus.
Yeah.
Now this is we need to compute this.
Isn't that ln of e?
Yes, write it as x power minus 2, right?
Yeah.
It's my power rule. 1 over x squared, let me do it here, equals 1 over like this, right? Now, taking out the derivative, how do you apply this power rule? How do you do it now, please? Negative 2 comes down. Are you following me?
Yes, following.
Multiply by x power minus 2 minus 1 minus 3. Here you have exactly negative 2 over x power 3, right?
Okay.
So here we'll have then, let me come here. So here 1 second will be uh, 18x minus 2 over
3
x power 3 plus what? Now the last one. What is the last time here? We still have here this 2, this one. How do you find that the derivative is a constant times 2 is a constant, right? Let me take that constant 2, and we take again the derivative of e power 2x, right? E power 2x. Good. Now, finally, then we can find the final answer. We can find the following. Why the second derivative is then equals to 18x minus 2 over x power 3, right? Plus, how do you now find what is the derivative of e power 2x again? Apply the rule. You did 2 times 2, it will be then 4 e power
2.
Right. Sorry. All right. This is the final answer. You can check if this is in the list of the options. You can try to manipulate and find it. This is the answer. Right.
Okay.
So the derivative of the root for the second derivative. Very, very elementary. Next time we will discuss like the optimization about how do we apply. That will be on Wednesday. I will be on leave. I don't know if my colleague will teach on Wednesday, but she will she'll inform you when she will have another discussion with you. I'll be on leave for a few in September. I'll be back somewhere in October, but we will communicate with you some subsequent discussions. We are closing now. Sorry for being a little bit for running late. But
Taya,
yes,
did you say that you're free to be contacted if I need clarity on something?
yes, please. Yes, please. My colleague.
Via email, or how do you want me to contact you, or Antas to contact you? Via email?
No, she's she's the boss of the module actually. Yes, you can send an email or an email. Yes, no problem.
Is that Nolwazi? Are you referring to Nolwazi?
Yes, he's missing.
I don't get responses from Nolwazi.
You will get. You will get response. She's always online, always there to respond. Please, she's always there. Okay,
can I ask?
Case, please. Yes, please, you can ask. Yes.
What is a particular question? Does it have to do with content or admin?
No.
Anything. Anything. She's very good. She's very good in everything. She will answer all admin questions. She will answer content questions. She will truly do everything. She tries all her best to answer all your multiple admin questions.
No, I was just saying, Prof, if she can and she's not afraid to post them on the discussion forums, she might find that whatever she's struggling with, her peers are also struggling with, and she might post it on the discussion forums.
Yes.
Assignment as well.
Yes.
Thanks, yeah.
That's it. Yeah, sure. Yes.
I appreciate
but please, you can also contact. You can also contact the tutors if you have also issues. But also, she always puts something on the forum. Yeah, but sometimes some people don't even go there to read what is there, and you'll be answering the same question over and over again because no one wants to go to the forum to see what has been said there. Okay, but thank you so much for
Just check as well where the recordings from the previous sessions, please.
Please, yeah, who can Musia, do you know where we can find the recordings for the previous sessions? Who can?
The last time I had them, they were on the respective links, but now those links have been disabled. That's why it's been difficult to download those ones.
Where can we now find it, at least for this one? Because I know some guys will ask
I know this one someone has been recording it. I don't know who's been recording it, but they can share the link with us as well because the chats have been disabled. I think that's why the link.
Who has been recorded? I mean, who? This one I started the recordings. Maybe it will be in my or somewhere there, but I don't know how even to
save them.
It will be on Teams under activity, Prof.
Under activity, sorry. Under activity.
Yeah, since you're the organizer, did you record it?
Yeah, he's recording it. It's being recorded.
Yeah, this one, yes. You mean under activity?
Yes, when you open up your Teams, it don't upload same time, but it will load there and tell you that you have a year to actually and before it expires.
You mean I go to Teams, right?
Yes, and then on your left pane.
Yes.
You would have activity, chat, and meet and calendar. So under activity, that's where you'd actually see the link.
Let me go there now, since you are still there, Mr. Let me go there now.
You have to stop the recording.
Yes.
I have to stop first the recordings. Okay.
Yes. Stop the recording.
Let me do so now. Stop recording. Yes. Stop recording.